Good morning to one and all. My name is Jinesh. Here the subject is electrical safety and safety management. The topic regarding to the subject is Introduction to Electrical Safety in High School for Prospective Engineering Students. Let we know the history of electrical safety. Thomas Edison is the first one who is said to have developed the first fuse by using wire between two terminals that would melt if too much current flowed through it. Here the figure given below is shown, which is nothing but the first invention of the fuse. Contrary to popular belief, Benjamin Franklin did not discover or invent electricity. The flow of electricity and its effects have been known for centuries, especially when traveling through air in the form of lightning. It was not until the late 18th and early 19th centuries, however, that scientists began to discover and analyze what electricity really is and how to harness it for man's benefit. Thus began the need to regulate the electrical installation to protect people and equipment from its unintended effects. With the advent of the electric light bulb and electric motors in the late 19th century, it was soon discovered that the electricity could also cause fires and kill people, though Thomas Edison is said to have developed the first fuse by using the wire. Here we can see a structural diagram which shows the inventions between 1860s to 1980s. It was first fuses developed in 1860s. AC and DC electrical system were expanded in 1880s and 1889 electric chair was developed and 1890s circuit breakers were developed. First NEC were released in 1897. UL with including UL. First edition of Electrician's Handbook is on 1913. 1940s, current limiting fuses were developed, and 1970 OSHA is formed, and like that in 1982 Ralph-Lee's arc flash paper was initiated. First burn counters opened in 1980. Like that, the structural diagram is shown. Electrical safety organization. We can see a number of electrical safety organization for the welfare of electrical workers. Here, OSHA, Occupational Safety and Health Administration, NFPA, National Fire Protection Association, IEEE Institute of Electrical and Electronic Engineers, UL Underwriter Laboratories, NEMA, National Electrical Manufacturer Association, ANSI, nothing but American National Stand Institute, ASTM, American Society for Testing and Materials, NECA, National Electrical Contractors Association. Several organizations have developed and continue to revise standards to address the numerous concerns involving electrical power. Standards and safety organization include shall furnish to each of his employees an employment and a place of employment which are free from recognized hazards that are causing or are likely to cause death or serious physical harm to his employees. Electrical safety codes and the codes standards. 20,000 plus standards have been developed to reduce the risk of electrical hazards. Working on de-energized equipment, if the exposed live paths are not de-energized, that is, for reasons of increased or additional hazards or feasibility, other safety related work practices shall be used to protect employees who may be exposed to electrical hazards involved. Such work practices shall protect employees against contact with energized circuit paths directly with any part of their body or indirectly through some other conductive object. Life support equipment, emergency alarm system, hazardous area ventilation equipment. These were the few methods that follow by the electrical person who are in the top-notch skill. Arc flash, other electrical safety hazards. Electrical safety hazards. When electrical system breaks down, what are the primary hazards and what are the consequences to personnel is electric shock, exposure to arc flash, exposure to arc blast, exposure to excessive light and sound energies. Secondary hazards may include burns, the release of toxic gas, molten metal, airborne debris, shrapnel. Unexpected events can cause stalled workers to lose their balance and fall from ladders or jerk their muscles, possibly causing whiplash or other injuries. A clear understanding of how electric current travels through the body can help minimize injury if such contact occurs. The table below outlines the effects that various values of current have human body. Here we can see a small table which is regarding to the current amount of current that was passed in a human body results what happens to the body. Suppose 1 to 3 milliampere of current would pass through the human body results in mild sensation. If it was 200-degree Fahrenheit, skin experience third-degree burns. Like that, we can see some more conditions regarding to the effects. Shock hazard analysis. Limited approach boundary. The limited approach boundary is an approach boundary to protect personnel from shock. A boundary distance is established from an energized part based on the system voltage. To enter this boundary, unqualified persons must be accompanied by the qualified persons. The restricted approach boundary. Restricted approach boundary is an approach boundary to protect personnel from shock. Only qualified persons are allowed in this boundary, and used they must be used PPE. The third one is prohibited approach boundary, which is nothing but an approach boundary to protect personnel from shock. Work in this boundary is considered same as making direct contact with energized part. Only qualified persons are allowed to enter the boundary. They must be use PPE. Yet the structural orientation of the approaching boundary is being seen in at here. At last, the conclusion is the most important rule for the electrical safety is to de-energize the electrical circuit before working on it. 30 feet to safety. Stay back at least 30 feet from any foreign power line or exposed underground cable. Look up and leave. Know your limits. Don't hang out around operating equipment. Shuffle or hop. Don't step. Thank you all.